So so in the last class, we were talking about list collection, right? So, and in that, we had discussed about different list methods as well. So the API of list, that's what we had discussed in the last class. We continue further on the same. So all this we had discussed in the last session about these methods like append, insert, and count and remove, pop, sort, and then we had discussed all this, and we also understood about what is list and purpose of list, all that. And also we had discussed like uh, different things like if it is mutable or immutable, if it is dynamic, all that we had discussed in the last class. And also we had discussed about the indexing concept of list. Okay. So I hope before that my this thing is visible and audible to all of you, right? Right. So please confirm in the chat box. So my screen is visible, right? Okay, thank you. That's fine. So now we had discussed all this as well, like adding elements, iterating a list. We discussed all this. Okay, and then we had done some couple of use cases on this list program, and then to do some such methods, all this. And also these things we discussed in the last session. Copy we had discussed. Methods all we might discussed in most of this we discussed. And also now we are moving to the next topic apart from the list thing we had discussed. Maybe one session we'll plan for the all these logics, different logics since the start of this Python, so that you get handy. You become handy with different kind of logics. Okay, so that way it would be very useful for all of you as well. How to apply all we have learned since the beginning of Python sessions, that we will do one logic implementation session. Okay, so that is fine. Now let us switch to the next topic of Python, that is tuple. What is tuple here? Tuple is also a collection like list. So it is a collection which is used to represent group of objects as a single entity. So that's a tuple here. I hope this is clear, right? So, and second thing, difference is it is almost similar to list, but the only thing is the list is dynamic, but tuple is not dynamic. Tuple is fixed in size. This is immutable, in fact. So you can see this is it is almost similar to list. It is heterogeneous and insertion order is preserved here. It allows duplicates. Duplicates are allowed in tuple. All this is fine. It's almost similar to list here. But the only thing is, what is this? How tuple is different from list? If you ask this question, the answer is simple. Tuple is immutable, whereas list is mutable. That is the simple difference between list and tuple, friends. I hope this is clear. So this is immutable. Immutable in sense, what shall we say? The once you create a tuple, then I don't think we can modify it. We can append or we can insert anything with the tuple. Okay, just a minute, friends. Sorry, friends. Yeah. So that's about simple idea. Okay, what is that? So this is immutable, means it's like fixed in size. We can say once we create a tuple, we cannot add some elements to that, and we cannot insert some elements to that, like how we did in list. If you remember, we are able to append some elements to the list. We are able to insert some elements into the list. We are able to remove some elements from the list, or we are able to pop some elements from the list. We did all these kinds of adding and removing and update operations on list. But if you ask about tuple, I don't think we have so many methods available on tuple. The methods which are applied on tuple is very limited compared to list. In that way, list is dynamic, whereas tuple is not dynamic. Which is dynamic, friends? List is dynamic. We can when we add elements, the size of list increases. When we remove elements, the size of list decreases. But tuple is not like that. Is that clear now? So, and the important thing about tuple is immutable data structure. Of course, it is also indexed and linear data structure. Like list, it is almost similar, but only thing is this is immutable, whereas list is mutable. And we can modify list, but I don't think we can make any big changes to tuple. Okay, then how do we create tuple? That is next thing. We can create tuple in two ways. Either we can apply this round brackets or we can use a tuple method. You can choose any one of these two, friends. Either like, if it is list, we use square brackets, right? Index what we call. Otherwise, we use list method, right? Similarly for tuple, what is that we use? We use this square, this brackets, parenthesis, or otherwise we use this method tuple to create a tuple. And also this indexing is applied even for tuple. If you ask about tuple, does tuple has indexing? Yes, this is a linear data structure. Any linear data structure or sequential data structure uses indexing. Like string, it has indexing. Like list, it has indexing. Then tuple has indexing. Okay, these are all indexed data structures. So when you create a tuple and assign some values, so what tuple does? Tuple uses indexing to extract values, right? So even though once it is a one-time addition value into the tuple, adding values to the tuple, but if you want to extract some values from tuple, then definitely what is that we need? We need indexing. Okay, same like how we did for string or how we did for list or how same thing we do for tuple. And this is how the indexing of tuple look like. See here, right? Suppose this is a simple example of tuple is like this. If you want to create a tuple, some data equal to open bracket something like 1, 2, 3, 4, 5. So but close this parenthesis. That's all. This is a simple tuple. And implicitly by default, Python uses all the it uses tuple as its implicit data type. I'll show you now what is that implicit data type. But this is an idea. Suppose if you create a tuple like this with some values 1, 2, 3, 4, 5, 6, then what happens? How this internally creates this tuple? How interpreter creates this tuple? You can see it is created like this with the 6 values, and this has indexing same like string or same like list. The index always starts from 0, ends with size -1. You can see here it starts with 0, ends with size -1, that is 5. Or it starts -n and ends with -1. And it has both the negative and positive indexing. So you can choose any one of these two. We can choose either positive index or negative indexing and to extract values from the tuple. Or you can use mixed one as well for slicing. Okay, so it's up to you. And another important thing about tuple is we cannot modify a tuple. It's not possible to change tuple. Okay, and then how do you extract values from a tuple? We extract values from tuple the same like how we do for list. We do the same for even for tuple. It's simple here. See, simply we can say some var name in brackets index. We should just apply the index. For example, so let me open PyCharm, right? So let's just take another folder here in the collection under collections. So we took collections, right? These are all belonging to the list. What I do is I create one more folder with the tuple so that all tuple programs will be in that tuple folder. Okay. So directory, I'm creating a folder and then tuple collection. I'm just saying a tuple data structure because these are all data structures and very useful things. Okay. And then under that, I'm just adding a new Python file. Let's just add some tuple basics. Okay, I'm just taking a basic testing. So I created a file like basics and closing all this. Let's close this. We don't need this now. We can close this. Okay, fine. Now let's create a simple tuple. Some t1 equal to parenthesis open, then add elements. Let's add elements. So just add elements here. 1, 2, 3, 4, 5. That's all. Enough. 5 is enough. If you want, you can add how many ever you want, friends. It's not like we should add only 5. So add how many ever you want. Now you need to print one by one. How do you print them? Simply say print of t1 of 0. Same like how we did for list. You can extract values like this. What you can do? You can extract values saying that t1 of 0. Again, similarly, you can extract value from a tuple like this, friends. Just a minute. Yeah, something like this. You can see, of course, 1, 2, 3, 4, because it has indexing, right? Indexing starts from 0, 0, 1, 2, 3, 4. Suppose I am trying to add some 5. What happens? Does this index exist? I am trying to extract element from fifth index. The question is this fifth index exist in the tuple? Answer is no. So if an index does not exist, still you are trying to extract an element from such index. What happens? Let us see. Of course, before we do this, okay, another this thing. Before we test that, let's first try to extract elements from the list and see what and see the all these values. Okay, right. Run this now, please. Let's run this program. Right click, run this program. And you can see all elements here. Maybe if you want, you can use this format method, something like the value in so and so index. You can mention the value in so you can add like this. This is much more index is like this, you can say, and then you can apply, close this double quotes dot, you can say format, and then and you can choose what you can say. Yeah, simply t1 of 0 again. Here you can pass two values. So t1 of 0 means it assigns that sorry, we need index, right? It is direct straightforward. It's 0. Come, the value in 0 index is, we can simply say t1 of 0. Something you can use format method to have more meaningful output, may have more meaningful result. This is very much I believe this is more useful for us. This format is much more recommended here than any other prints. Okay. So now here also we should not pass this thing. Put a placeholder for this. This will work now. Okay. So we put two placeholders. One for passing index. The value in 0 index is that, and second one to pass value. So we are passing index and then that value here. So this t1 of 0 represent value and that is placed into this. Similarly, what you can do, you can rewrite this with the first print here. Just take the value in first index. So just try to practice this as much as possible, this format method. This is much more helpful for you, okay, to have a beautiful output. Because even in real environment, for doing some testing or seeing some output, we use much of this kind of this format method in the real code. So like this, okay. Okay, let's run this now. Now you can see a more meaningful output, more understandable output. You can see value in 0 index is 1, value in first index is 2, second index is 3, third index is 4, fourth index is 5, something like this. I hope this is clear for all of you friends, right? Okay, this is fine. Suppose, I hope this is clear, right? This is the simple program to declare a simple tuple and then how to extract each element from tuple by applying index, right? While printing, we are just applying this format to have a better format. We are applying this format method. That's all. But a quick question. This is not just applicable only for list, I mean only for tuple. This is applicable even in list, even in string, or as well as all linear data structures. The question is simple. Suppose if a index doesn't exist, but still you try to extract that element from that index. Extract an element from the index, what happens? Let us see. Uncomment this. We know very well this index, this one T1 of 5 doesn't exist. Okay, because we have index still 4. But still what we are doing here, we are trying to extract that element from fifth index. Let us run this and see what happens at fifth index. We get output till this because this is interpreted language. So wherever we have error, at that line, it will throw Python throws an error. That's all. And now you can see at fifth, at this line 10, means when we are trying to run this fifth 10th line, you have an index error saying tuple index out of range because this T of 5 doesn't exist. And when that index doesn't exist, then we get an error called, what is that error? Index error. And it's clearly saying, what is it saying here, friends? A tuple index out of range here. Is this clear for you? So that is a quick idea, friends. Understood now? Right. So don't try to declare any index which doesn't exist in a tuple or list or string or all these kind of linear or sequential data structures. Okay. Oh. Okay. One more thing is, so you have a small announcement, friends. Maybe you can also share this with your friends or known people or anyone. The announcement is from Feb 1st onwards, we are planning again. This one Selenium sessions with Python. So we do the automation with Python, just a simple information. So if you are familiar with this, you can also come to an idea about how to do automation with Python in Selenium. That gives an opportunity to apply Python code on the other different types of technologies. It's a way of, you can have more opportunity to implement Python with that. Okay. So now that is an automation thing only. So maybe if you ask me, it is a testing, right? We want to be a pure Python developer, then do you recommend us to do that? Means my answer is yes, because still you have an opportunity to apply whatever you learn in these sessions in that automation. Okay, friends, anyhow, that's fine. So this is a quick program. Let's switch to the next one. This one, tuple. I hope you are clear now. So you know, right, how to extract each element from a tuple by applying this index like this. That reference of index. You know how this index look like in for a tuple here, right? So that's it, friends. Now let us move to and this is a quick difference between tuple and list. And people ask these questions in interviews. Actually, people ask a lot of questions in interviews. So whatever you are discussing here, all these are very useful. If you ask me, if you are trying to attend as a Python developer or as a automation engineer, or you don't need to be a tester actually only to get into all this. Even if you try to be a automation engineer, so people ask these questions. So what is this comparison? Always people ask, what is difference between list and tuple is the question people always ask us. Simple thing. The first answer always we should give in interviews. List is mutable, tuple is immutable. We can modify list, but we cannot modify tuple. Sometimes they ask you, is it really true that we cannot modify tuple? Means there is one exception in one peculiar case. I'll talk about it. But usually in general, tuple is we cannot modify tuple like how we do for list. Is that clear? I'm repeating. So a list we can modify, but we cannot modify tuple. There is a one peculiar situation where we can modify tuple that I'll talk about it. Even then, only that is specific to only that particular data type. That's all. Okay, we'll talk about it. But in general, what is it, friends? So do you think tuple is do you think tuple is modified? I don't think so. Tuple is immutable. Okay. That's it. And list is dynamic. Tuple is this is not dynamic. You can remove this. Okay, this is something I put it. Tuple is not dynamic if you ask me. Okay, and then a list is heterogeneous. Tuple is also heterogeneous. Both are other than these two differences. What is that? One is mutability, and second thing dynamism. It's a list and tuple are almost twins, almost like what shall we say, brothers or sisters. Why? Because they follow almost same features, except only in the this one. We cannot. This is not dynamic. Tuple is not dynamic, whereas a list is dynamic. Means list is growable and shrinkable, whereas tuple is not growable and shrinkable. Okay, so that's it. Insertion order is preserved in list. Even insertion order is preserved in tuple, and we can add duplicates to list. Same thing we can do for a tuple. Okay. And then we can do all other sorts of things except and methods. We don't have any API applicable for tuple. We don't have we have many methods to do operations on list, right? Like that, we don't have so many methods to apply on method on tuple except few. Okay, that's all, friends. Except some 3 or 4 methods, we don't apply many on tuple. But we can do the same. We have so many methods to operate on list. Okay, so that is a quick difference. And if you ask me how much frequently we use list or tuple in a real code, answer is both are real useful. We use tuple to implement your data processing, and even list also to implement in your data processing. Okay, so both are important. It's not like so, but anyhow, in majority of the cases, list has always an edge compared to tuple because we can manipulate data very easily with list. So list is most flexible to manipulate data than tuple. That's why a list has an edge compared to tuple if you ask a precise question. Okay, is that clear, friends? So that's the simple idea about list versus tuple. If anybody asks you an interview, you can easily answer these questions. What we can do is you can take a few interview questions at the end of this session today. Okay, let's switch to the next topic. I hope this is clear, right? That's fine. Next one is uh, altogether we have gone to exception handling. We had gone to OOP from here. Okay, no problem. I think these examples are there in the this document. That's why I opened this. So let me just check with tuple. I can see here. Let's move on this. This is the tuple topic. You can see this is how we create a tuple. One approach is this in the program. What is that? Creating tuple with parentheses like this. Second thing is to create a tuple. You can also use tuple method, TUPLE, and then to create tuple, these methods like list method, tuple method, set method, or dict method, we cannot pass a single element like this and create a tuple. These kind of methods expect iterable objects, like it expects this collection object. So to this, if you want to create a tuple, already we know how to create a list. We can pass a list as a this thing to this, like we can construct a tuple from a list here. We cannot directly pass independent elements. It won't work in Python. So whenever we use these methods like tuple method or list method or that bytes method or byte array or these things, these kind of methods, we have to pass collection or iterable object as a input. So that's why if you see, while constructing this tuple using tuple method, what I am doing here, I am using a list here. I'm passing a list as a input so that this list gets converted to tuple. Okay. And this method also acts as a conversion method. If you want to convert any of these different data structures to tuple, then we can also apply this tuple. Suppose if you want to convert any data structure to list, then we can choose list method. Suppose if you want to convert any data structure to dict, then we can choose dict method. In that way, and the another purpose of these methods, this built-in methods is they can also use as conversion methods, and they can be used in two ways. Understand this carefully, friends. One, they can be used to construct empty data structures. First thing, see, if I don't pass list and if I just simply declare this method here, tuple method, it creates empty tuple. Suppose you see here, simply if you print it, print of T2, see, just print it and run this code now. See, I didn't pass any value here. Then this returns an empty tuple. Okay, when we print a tuple method, just if you just create a tuple method like this creates empty tuple. Okay, right click and then say run tuple basics. You can see here, it is giving you empty tuple here. See in the at the bottom of this in the output. So are you seeing this empty tuple here, friends? Right? So that's what happens. After that, next one. Suppose you are adding some values to this through some collection by passing some collection. Usually by now we are familiar with the list collection. So pass a list here. Now when you pass a list to this, then what happens? A tuple is created with 5 elements, 1, 2, 3, 4, 5 here. Okay. Now right click and then run this. Now this time you can see a tuple with 5 elements here. This is how tuple look like. If it is list, we use square brackets. If it is tuple, we don't use. That's how Python uses. Okay. So for tuple, it uses this parenthesis. Now this is how you can create a tuple with tuple method. Right. I hope you got an idea. Maybe if you ask me, can we dynamically add data to the tuple? Dynamically means while running code, if you want to insert data, then that we cannot directly add data to the tuple, but we can do that through some list or something. Okay, maybe I'll talk about those use cases later. But point is, we cannot directly modify tuple. That is the answer. Straight answer is no, we cannot modify tuple. If you want to do that, we can no, pass a data and recreate new tuples every time if you want to update tuples. But directly it's not possible. If you're asking me if you want to modify it by adding element by element or something like that, it's not possible. Okay, so that's a simple idea. But anyhow, I don't want to confuse you. As it is a immutable data type or data structure, we cannot modify tuple. That is the answer. Okay, fine. And we have seen two ways of creating tuple, either directly creating tuple with this. This is the first approach. And second approach is by applying this tuple method, we can create this tuple. So using tuple method, we can create tuple. You can see this. And for that, we need to pass iterable object as a parameter. All these methods accepts iterable objects in the form of some collection, in the form of some data structure. So as we are familiar with list here, I am passing list as a input to this tuple method. I hope this is clear for all of you, right? And if you want to extract, even it is same. Once we pass data, the internal data structure is same. Even same for first approach or same for second approach. And this also has indexing like how we have for the first declaration. And if you want to extract this data, then you can apply this indexes like this. I hope this should be very clear for you, right? Now, third scenario, iterating tuple. So generally, in a real time, extracting elements with index doesn't happen very frequently. That is not a frequent operation. It's very rare you do it while doing some kind of testing, that's all. But in majority of the cases, when you work with these data structures in a real environment, we apply iterators to iterate these data structures. And that too, for is the most used the most used iterator. More than while. For is very much familiar. Okay. So now, how do you iterate it? Simply for some T1 in some T in tuple in T1 colon. Just print T. That's all right. You don't know how, right, how this iterates. This is a collection. This is a dummy variable. Every time this for loop iterates, one element from this collection is copied to this T and that element is printed. This is the very simple, very sophisticated and more simplified iterator. Okay. Now when you print it, what happens? All that elements will be printed from the tuple T1. Maybe if you want to print tuple T2 because you are already printing values from tuple by using index, maybe let's iterate T2. if you want to do this, just change values here instead of 1, 2, 3, 4, 5, you 10, 20, 30, 40, and 50. So that now you can see we are iterating this tuple like this. Okay, right click and then say run tuple. In the second case, you can see the output from the iterator here. So it's printing all that values from the type 2 declaration, that is T2. I hope this was clear for all of you friends. Are you clear now? So that's the quick idea about this. Suppose I want to add all elements of a tuple. I want to apply a small logic. So now what is it? Logic time. So simple logic time. So how do you play with this tuple now? Suppose this tuple has some values, right? Now we should play with this logic. So how do we play here? Simple, right? Simply iterate a tuple. Which one shall we use? Shall we validate here? Let's use this T1 tuple because it has combination of both even and odd numbers. So let's do a small program. Of course, for this logic is now I am doing sum of all numbers in a tuple. For that, you can apply either T1 or T2. Anything is fine for some. But if you want to extract odd numbers or even numbers, then this is good example. Okay, choose this tuple. Okay. Now, so let's do some logic here. So what is that logic? Adding all elements of tuple. That is the quick example. Let's play a bit with tuple here. Now for t in P2, what shall I do now? Colon, simply. But before that, if you want to do some, just declare a variable. Do you think really need that in Python? Just yeah, declare a variable sum and assign it to 0. Sum is actually a built-in function again. Maybe if there is any conflict, just change that variable to someone. Okay, no problem. Now the logic is sum equal to sum1 equal to sum1 plus that t. This gives you sum of all those elements in the tuple, that T2. Okay, so here T2. That's all, friends. Now you print this. What is that print? Now copy that one. I think this is much more easy for us to print. Okay, print the output. What is that? The value, the sum is the value, the sum of. You can use T2 is you can use two placeholders here of from which list you are getting the sum and what is the result actually. So you can use what is the sum of you can say in double quotes, pass double quotes T2. Just passing that list here. The sum of T2 is what you can just simply say sum1. Right. So this gives you the sum of all elements in a tuple here. See, tuple has these elements. Where if I am applying T2, then what is that? Or T1, anything is fine, friend. Sorry, I told you to choose T1. In this case, for to do sum, we don't have a big issue. You can choose this tuple or this tuple, any of these two tuples. It should be fine for us, friends. We don't have a problem. Okay. So we are applying T2. If you want to do this sum on T1, just simply change that reference name. If you pass T1, it will apply sum on that T1 tuple. If you pass T2, it will do sum on that T2 tuple. That is the difference. That's all, friends. Nothing much difference here. We don't have big difference, right? Run this now. Now see syntax error while passing at line 24. Where is the line 24? Okay, we have to close this. That is the error. Okay, now run this. Okay, intent tuple, unsupported operand types plus sum equal to, yeah, sorry, I'm adding sum1 plus T2. That won't work, right? So we have an issue with the logic here. So anyhow, we have corrected it now. It should work fine this time. Run this. Now you can see here sum of T2 is 15. Okay. Sum of T1 means, so this is anyhow, we have to make a small change. This is, we are not doing addition on T2, but we are doing addition on T1. Change your output statement here. That's it, friends. Right click and then run tuple. You can see sum of T1 is 15. This is a simple this thing. How to add all elements from a tuple. That's the simple program. Suppose another simple use case on tuple. How to print all odd numbers from a tuple. Excuse me. Print all odd numbers from a tuple. So how do you do that? This is a simple program, right? Copy this iterator, friends. It's a very simple one. So maybe you apply this logic on tuple T1. On which tuple you apply? T1. As T1 has both even and odd numbers, I recommend use this logic on T1. Now, same thing, copy the iterator. You don't need to sweat much this time. So for T in T1, simply you can apply. You should add a validation. What is that you should do? Add a validation. Okay, validation. What validation? Even or odd validation. Add a even or odd validation. But this time I am asking you only just print odd numbers. I am not asking even numbers. So what should you do? This is just a odd validation, not even validation. I am not asking for even numbers. So what do you do? Under this, if the t percentile 2 equal to 1. So this is a straightforward validation for odd numbers. Then what is that? Print that t for that element. Over. This is a simple validation for what is this? Validating if a number is element is even if the element is odd or not in a tuple. Simply print it. So maybe you can print this, right? Simply just print it. Now you can see we have all odd numbers here, 1, 3, 5. So this is how you can play with tuple, by using that data in the tuple. I hope this is clear for all of you friends. That's the simple idea here, friends. Right? Are you playing with this code here? Just you can keep testing your code like this by applying as many logics as possible. Right? Okay. Now let us see what else we have on tuple. We know now how to access elements from tuple. This is how we access. Also, if you want, you can apply slicing. Slicing in sense like this, friends. See here. So this is slicing time now. What is it? Let's slice and dice your tuples. Slice and dice tuple. Means breaking or splitting tuple and breaking into parts. Like how do you do this? What is this? You know, this audio thing, video thing. You do this editing, right? It is more like editing a tuple here. So how do you do? Take some new tuple. Otherwise, instead of using same tuples, you can do one thing. Let us add some data here. Tuple can have heterogeneous data. It's not like it should always has homogeneous friends. So if you want, you can add some decimal data 10.5, 8.6. Also, it can have some strings, something like nom tech. Okay, it can have some strings like this. Okay, nom and then comma tech. Okay, and then something like this. You can add strings, something like so enough. Okay, let's enough. Now you want to apply slicing, right? How do you apply slicing? Slicing we discussed a lot in string topic. So let's apply it. This is slice time now. Let's do how do we can slice it? Suppose I want to extract. Let us see this. This requirement is this. What is the requirement? Break this tuple based on what? Based on data type. Data type. It has integers, it has float, it has string. So now I need to break this one tuple into three subtuples, small tuples. One tuple should have all all integers. One tuple should have all decimals, you can see this tuple has different data types. So we have an integer data in this tuple. We have a decimal data in this tuple. We have a string data in this tuple. These strings you can choose whatever you want, friends. I choose nom and type. You can apply what you want. You can add whatever you want. Now, this is a big list. This is a big data set. Assume that. Now I want to break down into small data sets, small tuples. Then what can I do? Simply, you can up slicing is one best choice. And here these 5 elements are integers, and the start index and end index. Then in such case, what? So what you can do? In such case, you can split this tuple from 0 to what is this? 4. This gives you which tuple? Tuple with all what, friends? With all integers. Similarly, check the index for this. Similarly, these two. Check the start and end index for these two. Okay. In that way, we can break down this big tuple into some small tuples with the unique this with the specific data types. Okay, but if this should happen dynamically, suppose assume that there is some thousands of elements in this tuple, and in that case, you don't have opportunity to observe what data is visible here. But the requirement is someone your stakeholder is asking you sort this data based on data type. The question is sort data in tuple based on data type. And now this is a small tuple. You are able to see how many elements are there, and you are able to check the index. Suppose if it has hundreds of elements, and it is clearly saying that this tuple has int data, and then it has decimal data, and then it has string data. They gave you this requirement. Now sort this data based on data type. They ask you all integers should go to int tuple. So requirement is this. What is that? All integers should go to int tuple. Okay, that is one scenario. And this has to happen dynamically. Static way, it's so easy. I'll show you both approaches so that you understand how to play with data when you are writing code for real use cases. So next one, all decimals should go to decimal tuple, or that float, all decimals should go to decimal tuple. That is one more scenario. And third one is all string data should go to all strings should go to string tuple. So we should create 3 different tuples. We'll see this application in 2 approaches. One, as we know, this is a small tuple, and we know the index. We can easily observe the index, and we can apply slice directly. That is one approach. Second approach is if the same thing, assume that if you have hundreds of elements, but you don't know where the index of that integer starts, where the index of integer ends. In such case, how do you do this slicing on this tuple and try to push those elements into the respective tuples, like integer tuple or decimal tuple or string tuple. We'll see both approaches. So all strings should go to string tuple. That's it. So this is a small use case which we can be used in a real time as well, because we keep doing these things. This is very important for you. First, now simple scenario, approach 1. Let's apply this approach 1. You can also parallelly understand these things. Okay, observe this and apply it along with me, friends. So first is I need let's take one tuple, that is int tuple. I say int underscore tuple equal to, simply apply a slice here. What is the slice? T1 of 0, or you can just ignore first start index here. Why? By default, this tuple starts with 0 and they starts with an integer. So I ignored that start index. Now 0 to these integers are there still up to 4th index. So you should say 0 to 5. Then it takes up to 4. Okay, this gives you int tuple. That is one thing. Second thing, similarly, what you can do, you need double tuple. So, okay, or float tuple here. In that you have 2 float elements. These 2 should go to that float tuple. Okay. So now you can simply say float tuple equal to, and apply slicing again, T1 of, okay, or you can give T3 because we have T1, T2 already. Give this T3 and apply T3 here. That would be fine. And T3 off. What is that now? You applied, you extracted, what is this one? Into tuple. Now we should extract decimal tuple now. We should get these decimal elements and assign to this float tuple. For that, you can simply say this is what is the index of this? This is fifth index, right? 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is in fourth index. This is in fifth index. So you should mention here. We have to mention start and end index. What is that we should do here, friends? We must specify start and end index. Why? Because this is in the middle. Middle doesn't have any exception here. So mention where that decimal starts and where it ends. It starts with 5, ends with 6. If it ends with 6, then mention till 7. So 7 is ignored. It is exclusive, not inclusive. That index is excluded. It won't consider that ending index here. The 7 is excluded. So you can add 5 to 7 means it accepts. It try to apply slice on which indexes, fifth index and sixth index. It won't apply on seventh. Seventh is ignored here. Is that clear? Next one after that, string tuple. Here simply again T3 off. Now I want to get these two. As we are doing it in a sequential, slicing is applied on a sequential this thing. We know now norm exists in seventh index. So 7 colon. I don't mention the end index. Why? Because the rest of the elements are strings. So how many other elements are there after 7? All that will be assigned to the string tuple. Is that clear? Here all these are aligned like this. Suppose if it is in the random order, suppose some integers, some decimals, some strings all mixed together means then you have to go with a different approach. We'll talk about it after this. But this is a simple idea how to break down a tuple and arrange elements according to the data. Okay, how to split that tuple into small tuples according to their data type. So this is how we can do. All integers we move to int tuple, all decimals we move to float tuple, all strings we move to string tuple. Let's print and see the output. Okay, so print. What shall we say? You can apply format method again and again. Copy this. This is the best print method you can use all the time. Not only in your code, you practice here tomorrow when you do testing in your projects as well. Okay. So here you can simply say we can simply pass what I'm passing the int tuple, that name of the tuple and then values. Okay. Is the elements of elements of that what is that here you can simply say name the int tuple, pass that int tuple here and then remove this. Now pass that variable. One is in string, that is going to fall into this placeholder. So this string will fill into this first placeholder, and then this variable will fill into this second placeholder. Okay, so that's it, simple. Now similarly, two more prints for us to print data from into tuple, then float tuple, then string tuple. Just make some small changes here. Instead of int tuple, here just change it to float, and here also they change the variable name here, float. And then here, instead of float string, change it to, instead of, sorry, int, change it to string. Here also, change it to string here. That's it, over. See, it's showing some error. See, what is the error there? So, why error? Somewhere, oh, got it. Close one more bracket. See, you have to observe errors as well. Suppose if you see any red marks in the or red lines in your code, make sure that you are having some error in the code and you try to fix it. That is very important, friends. Okay. So now run this. Now I hope you understood this logic, right? This requirement. This is a simple thing. Maybe I don't see any complexity in this. Did you get this logic or this requirement? Did you get this problem, friends? Can you please confirm in the chat box? Are you able to understand this requirement and this solution as well? Okay, thank you. How about others, friends? Are you good with this problem? Understanding problem is the half. You are good with half of the solution. Okay. So that's it, friends. This is okay. This is one approach. Let's run this. Still, we didn't run this yet. What do we do now? Let's apply. Let's run this and see the output. See here, int tuple, all ints are sorted into the int tuple. All decimals are sorted into the float tuple. All strings are sorted into the string tuple. Excuse me, friends. So this is a simple idea. Okay, this is one kind of doing playing with that tuple. See, we applied many things we learned in the past sessions. What we applied slicing. Now we slicing is handy for us. Now we know how to apply slicing. Slicing syntax is simple, right? Whichever the data structure you want to apply slicing, what is that you should do here, friends? Simply take that data structure name or collection name and apply. Slicing means you have to split. What is the start of that data structure, end of that end element of that data structure, where you want to apply slice or where you want to split. Then choose that. That's all, friends. Okay. So by default, if you don't pass anything means it's by default starting from 0th index. So even if you want, you can pass 0 or you don't need that. That is not needed if it is starting from 0 itself. So that's why I didn't pass 0. Wherever in any code, if you see this means, it means by default it's starting from 0th index. That's the meaning of this, friends. Okay. And similarly at the end, if you don't see anything, any index passing here, means it will take rest of that list from 7th index onwards. Of course, we have just only 2 elements after that, nothing much there. This is fine. There is another scenario. Maybe you need to sort. This is, let us take tuple 4 now. So this is actually already data is sorted here in this tuple. So that our job became easy to apply slicing. Suppose if your tuple is like this, or if your list, even the same thing you can apply on list as well, same logic. Instead of tuple, you can use that list thing. That's all, list data structure, right? This logic can be applied on any kind of data structure, same thing, right? Even the same data can exist in a list and you can do the same thing on that list as well. Okay, now copy this and another scenario for you. This time problem is almost same, but with small change. What is it? I believe this time I don't think you can apply slice, but you have to choose a different approach of logic. So this is requirement. Almost same requirement. Sort data based on data type. That is fine. And all this is same. But here, this is not what is it? Ordered. This won't be sorted a tuple now. Now here elements are given in some order here for us. Okay. But what you do? Just a minute, friends. Okay, sorry. So this time let's have, this is not arranged according to this thing. This is mixed data. I mean mixed tuple. So what is this? Let us just show you. Your tuple is like this. All elements are mixed but not organized like this. Something like 1, 10.8. So this tuple is more organized. All in one, in the first place, and decimals in second place, and string in third place. This is a much more organized tuple. But now let us take unorganized. I'm not saying ordered, organized. Ordered is different, organized is different. So now let that string be here nom. In between nom, you add 2 and a comma. Again, after that, you add some decimal, some 9.8. You can choose anything of your choice. Elements, it's up to you. I'm taking like this, okay? And then after that, again, some 3, again, some 6.9. Maybe if you want, you can add one more data type as well. What is that? You can add a Boolean as well. So now this is unorganized tuple. We have a data set here. This data set is not organized according to some data, like all ints first and decimals next and then string later. So this is mixed this thing. Now what is the requirement? Requirement is same. We have to sort this data based on this data type. But if you want to apply slicing, slicing is very tedious job here. You should first get this and then get another element and get another element like that. But this is so tedious process. Suppose if you have just some, how many elements here, friends? We have just some 7 or 8 elements. That is fine. Suppose if you have hundreds or thousands or lakhs of elements, then you have to go for a dynamic logic, not a static logic. So how do you apply a dynamic logic here on if you have hundreds or thousands of data or lakhs of data in this data set? We can call this as a simple data set, friends. Right? How do you apply that? So now that is the logic we should understand first. Let's apply the algorithm first. How do this is a simple algorithm. First, this is unorganized data, and now you have to sort this data according to the data type. That is fine. So what shall we do now? First, you are already all of you are really familiar with one thing. You know how to find out data type of some data, right? Are you familiar with or not? Find the data type of your data. This is the first thing you have to. Something should strike our mind. If you want to solve this kind of logics, the important thing that should strike our mind is we should have a clear idea about that type method, or we should find that data type of each data here. Find data type of each element. Okay, and based on element, you should create first here, as this is tuple, we cannot modify tuple. What you should do is first create 3 lists here, because we have 3 different or four lists here. One list is what? One is similarly same like this. So one is an int tuple. You can copy and paste these 3 and add one more Boolean tuple. Okay. So now you can add one more tuple here. Boolean, not tuple, Boolean list. First copy all your data to list first. For that, for the first time, first create empty list here. Don't create tuples, because tuple directly we cannot create now. While doing operation on tuples, splitting this data, so sorting this data. So what you should do, if you create empty tuples and you cannot append data, you cannot modify tuples. So choose list here. See, we are trying to understand a different level of programming here. When you want to do some operation on tuple, we cannot do directly on that. So we take support of some dynamic data structures here. So this time we are choosing list here. So first create int list. We convert this again to tuple back. If you want the output to be in tuple, first what we do, we extract all that data to the list and apply that, pass that data to the list, and then again convert to the tuple, and finally we provide output in tuple format. That's how we have to do the operation when you are dealing with tuples, friends. Got it right? Why? Because tuple is not mutable. It is immutable. It is not dynamic. So we cannot modify it and we cannot manipulate it while doing some processing. That's why what do? We apply operation on tuple, extract data, convert it to some list and do some dynamic operation, again convert back to tuple. This is how we should do. We should play with tuples in a real environment. Is that clear? So this is int list. So float list, and then string list, and then Boolean list. This is fine. These are all empty lists. Why I created empty list? Because this tuple, assume that this is a very big tuple. I don't know what different types of data it has, but clearly the stakeholder is saying that this has only four different types of data. It has int data, float data, string data, and Boolean data. And the stakeholder is asking us to break down the sort out this data based on data types. So these 4 data types is the requirement, is the problem. In such case, what we do, we create 4 empty lists now according to that data. Now iterate this tuple. Step 2, next logic. In this approach 2, the second part of algorithm is iterate tuple. So that's what you should do. If you iterate, what happens? How to iterate? You know very well. For T in T3 or T4, which is this. Already T3 is there. Let's put it as T4. Now for T in T4, this is simple. It's not something really difficult. T4 colon. What is that you should do? Simple, friends. You have to check every time you iterate, one element is copied to this dummy variable T. Now you should check type of this T. Is it int? Is it float? Is it string? Is it boolean? If it is int, pass it to append that data to int list. If it is float, append that data to float list. If it is string, append that data to string list. If it is boolean, append that data to boolean list. That's what you should do. So what is that the validation we should do here? If okay, type of what is that? You know how to check the type of some element, right? Type of T equal to. So if it is what? If it is int, you can see here. You can directly check with that data type. If it is int, then this. So you are what you are trying to do. You are trying to iterate this tuple and get an element to this T, and every time some element is there in this T, we are validating. If that type of that T is int, then we should push the data to the int list. We should push or add that data to int list. Simple. So what do you do now? Int list dot append. So you know, right? If you want to dynamically change the list, we can use append method, not insert. Okay. So add that T to that if it is an int list. Else what? We have hardly 5 or 6 data types. So this kind of if construct is always recommended in a real Python code. Okay, elif you can copy this every time, you don't need to write it. Simply else what? Just pass that here. Type of T equal to some anything of your choice. It's not like it should be float, right? See the implicit, you know, right? Each element has an internal data type. So, you know, right. So pass it as float. If it is float, then add that data to float list. If the so see how simple this is. This is how much our whatever data it is there. You don't need to know. Now we just check the type and just move that data to the that particular list based on that type. So in this way, what is that? You don't. This is a dynamic approach. Even whatever data that is there inside that tuple, we don't need to worry about that. Okay. So now move this data to float list and then float dot append and then pass that T. That is fine. Again, similarly, elif one more. Right. So this is more like switch case in Java. If you are from Java or C or C++, building a simple switch case based on that data type. Okay. If it is str, right? The another data type is str. Then you have to add that to str string list. Okay. String list and then and finally else remaining is this which one boolean. So you can simply say boolean list dot append because that is the remaining one. You don't need to do any validation again for the last time. Okay. Append dot key. So we created 4 lists now. Now what do you do? Print them. Just print all those 4. Later on again we convert back them to tuple again. That list we convert back to tuple. This is actually a dynamic process to sort data according to data types. Now whatever data it might be inside that, then you can this logic helps us. Okay. Now format dot this one is a int list. Okay. Float list. Okay, and then string list. And here string list. See, I know I am spending time to make sure that you are also having some hands-on with the code as well, friends. Okay. It's not just the topic we do. It's about again getting hands-on with the how to apply it is also important. So blindly, if you just try to learn all that, that would be okay. But applying helps you more. That's what I am spending time here, friends. Boolean list. Then you can say, what is it? You can simply say here. Yeah, you can choose from this one. It's now run this. See if this data is organized or not. You take how much our data here, right? You pass 100,000, then of course it has to fall into these four categories. That is important. That is the rule. And you pass any number of elements to this. Still, this logic will sort out all that. Okay. So now let's run this now. You can just focus on the last output. Of course, you can also add a print for better this thing here. What is that? This is for program one. This is for program two, like that. Okay. For now, I'm not adding that, but you can do that. See, writing program is one thing, and adding comments is the other. It's very important thing. Many people don't usually do, but you have to habituate adding comments. Third thing, giving proper output statements so that everybody understands your output. That is the third practice we should do. When you are working in a real program, these things we should adopt, friends. This is very much needed. Okay, try to start habituating that when you are writing code. Okay, and giving proper variable names, meaningful names is also very important. Okay, let's run this now. Now you can see here, this is somewhere, we can see here, this is int list because we are dealing with list now. We extracted all that elements from tuple to list. By iterating tuple, we are validating that type and then we are pushing that data to that respective list here, right? You can see int list has all integers, float list has all floats, string list has all strings. You can see last four statements, 4 lines of output here. And we have Boolean and Boolean. You can see this is sorted very well without any much issue. You can see this, friends. Got it? Now, another scenario. Converting. See, we don't need this output in int for this list format. We just take, we took a little help of list so that it is dynamic. So we can validate that and add that data to the respective list. And then again, this data has to be in tuple format only. It should be in a tuple format. It should not be in list format. Then what do you do, friends? Simple. What is that? Simply, again, another thing, converting back to what, friends? Converting back list to tuple. What do you do here now? All these are very important for you. Okay, whatever we are doing here is very useful to you. Tomorrow, again, remember my word, mark my word. When you are working, if you are really having any need and working in Python, you remember my words when you are doing these use cases. Okay, converting back to list to tuple. What do you do here? Simple, right? So to do this, we have this conversion methods like for tuple, directly use tuple method. Tuple method is not only used to construct empty tuple, it can also used to convert that any data structure to tuple. So how do you do this now? So simple, simply you can now choose the names like this. Instead of int list, all this. Okay, let's do one thing. Copy this and paste it here. And first one, instead of int list, give it as a int tuple. Okay, we'll do the conversion again. First, let's declare variables float tuple and string tuple. Okay, and boolean tuple. Okay, like this. Okay, you remove this. These are not important. Now remove the brackets. Now here simply say what is it? Tuple. Use tuple method. Put brackets, and now you should convert this int list to int tuple. How do you do? Copy that int list and pass that int list to the tuple method. Then this automatically gets converted to which one, friends? This int tuple. Now this int list gets converted to int tuple. Similarly, do the same for remaining 3 statements. You can try for remaining three declarations. Now instead of tuple, instead of int, you choose float list and pass it to the tuple method. Then this gets converted to which one, friends? Float tuple. And then again, copy string list and pass it to the tuple. Then this list of strings gets converted to a string tuple. Of course, data will be same in all this, both tuple, both this thing data structures. But That data structure type changes. That's it. We are converting list to tuple here. That's what we are doing here, friends. You got it right. And then what else we do? Let's copy this, friends. And then we paste it here and then save it. That's all. And then print it like the same thing. But here this time we are printing what? We are not printing list, but this time we are printing what, friends? We are printing tuples, converted tuples here. Okay. So instead of list, change this one into tuple and then print into tuple, tuple, and then float tuple and then print float tuple, and then string tuple. Okay, and then print the. Tomorrow we'll finish off. We'll switch to set and dictionaries. Probably we'll try to close this data structures. This thing. Okay. But it keeps coming. Whenever it keeps coming, we keep doing some kind of this thing there. Okay. Boolean tuple. Change this to Boolean tuple, and here also change this to Boolean tuple. Okay, that's it, friends. So maybe you can add this output for tuples like that, but it's okay, fine for now. So what do you do right now? Otherwise, if you want, just add it like this. Simply, you can remove all this. This time you don't need it. This format is not needed. So the tuple data, you can just add like this simply. And just say something like this, put some lines like this. You can just organize, format it as you like, friends. I'm just adding like this. If you want, you can add in a more beautiful manner. And this is what, this is all list data coming from list actually. Similarly, you can print remaining as well. Let's run this. Let's not waste much time. Now you can see here all this list. You can see here. These are all. This is a list data. Okay, all these are different types of lists here. They got converted to tuple here. See here, friends. Right? This is a simple idea about. We did different use cases here in today's session. See here, right? So this is a simple and dynamic way of what is that sorting data according to data types. This is very important. Remember, this approach is important. Okay, just have this thing in mind. Okay, friends. So that's all, friends. This about this. I hope all of you are good. Do you want me to copy and paste this code in the chat box, or is it okay you have already copied this? Shall I paste it this all the whole stuff in chat box? Okay, see here, I'm pasting. Okay, you can copy it, friends. If you want, you can copy this. Let's just move to the next topic. We'll close this tuple today and then jump to the other topic. What is it? Set and dictionary tomorrow. Very useful. Dictionary is very much used. Even list all we cannot say which is very set. We don't use much compared to these three. Among these four, we have four more. What is the four data structures? The highly popular data structures in Python. Among that, dictionary and list is very much popular. Quite often we use these two, and then comes to the next level comes to the tuple, and then set. That's all. Okay. If you are really mastering these four data structures, then you almost mastered some 40 to 50% of your Python scripting. That's it. Apart from that, you should be good having a decent knowledge on basics like this iterators, this loops, this decision statements. I think you should be familiar by now with all that. Then you are almost ready to do certain level of automations in Python. Is that clear? Okay. So let's move to the tuple topic now. So these are all, see, we don't have much methods in tuple. Tuple has only few methods, friends. One is index method to get index of something, and then count. That's all, these two. We don't have any other methods like how we have in list. We don't have append, we don't have insert, we don't have pop, we don't have remove, we don't have copy. I don't think we have all such methods that in tuple class. Tuple has just only two methods. One is index, the other one is count. Index returns index of your tuple, and then count returns number of occurrences of some element. We already know what is the purpose of tuple. So, but performance wise, tuple is always better because this is immutable as we don't modify it frequently. So this has a better performance over a list here, friends. But anyhow, let's quickly test these two examples. Let's take a simple tuple here. Let's use this example itself. Okay, you can see here now. This is the example. Let's test these two. We have two methods. We are testing index now, index method on tuple class. So this is the example code. We are just simply taking a tuple. This is assume that what is this? So this is which tuple? T4. Let's apply T5 here. We created fifth tuple for today. This is a mixed data with what? See here one more important thing. See here, this tuple also have data structures inside that. It has a list inside tuple. You can see here now. It has integers. C means what? A data structure, any data structure, it can be a heterogeneous collection of data. And in that heterogeneous data, you can also pass your data structures also as elements. You can see we pass list as an element here. All these three elements, this whole list is treated as one element here, not three elements. Don't get confused. Because this data structure, the whole data structure is treated as one element in this tuple now. I hope this is clear now. Now, this is a simple tuple we created with mixed data. Like, we have integers, we have a list, and then we have a string. Now, I want to get the index of this particular list here. Then how do we get the index? Simply, you can apply index method and just pass that list to that automatically. In this one, in this particular list, what is the index of this one? It is written. You can see 0, 1, 2. This index of list starts with third index. So it is in third index. It is sitting in third index. So it prints 3. Right? So run this now. But if you want to run first, you should print it, right? So here print, directly print. So you can copy this format method. Now we became very much fond of format now. So here, simply speaking, the instead of elements, you can say simply the index of, so some list is something. Okay, like here format dot index of, this is the value we get. Okay, no problem. First close this, and before this you can just pass a string index here, so that index of, sorry, pass the list here 4 5 4 comma 5 comma, both should be passed as values only this time, no string filling the placeholder. Okay, this is the thing here. Now what we are doing here now, the index of this is format dot, I don't know why it happened, why this is not okay, this should be fine. Oh, warnings and errors, no problem. Okay, so this one we closed it, comma, and then t dot index of 4 5 6. We are seeing errors, and close this. Okay, this is fine. Format, we are passing this as for first placeholder, comma, index of, this is for second placeholder is 4 5 6 is, this is fine. This is actually SC. This is why we have an error. Okay, that is actually, if you want to add some comment, some output, use this Python comment. Okay, // is Java or CPP or CPP comments. Okay, now this should be fine. Okay, let's run this now. Still, I am seeing an error. You can see one error is there. Where is that? 4 5 6. This is fine, comma t dot index of. So here.
One more parenthesis, I think.
Yeah. Let me see. We have One more parenthesis. Yes, for index we closed. Correct. Perfect. So warnings you can ignore. Don't care about warnings. You can ignore it. This is perfect, friends. Let's run this now. So now you can see here. Where is the
Is
output?
T5.
Oh, again,
T5
that's why it's showing some this thing. Got it now. Yeah. Lost in transition. This is called. Okay, no problem. Yeah, thanks for the correction. You can see here now the index of this 456 is what here, friends? This is 3 here. I think we are good here now. Got it? This is how we apply index method. You can see we just apply index and pass some element that index method returns that index of that element from that tuple here. Here it should be that specific tuple here. Okay. So that's done. Next one, let's move to the count. Count is also simple, friends. See, we already discussed this in list. Also, same can be applied on string as well because these are all almost similar data structures, linear or sequential data structures. Okay. So what you can do now, example, again, one more program. So here this is, you can take T6 and then T6 dot count and this change this one. So now you can see here in this we have repeated occurrence of some data. We have 10 is repeated for twice and then 20 for twice, 30 for thrice. And we have some this one, some collection in that. Okay, that's fine. Now we are trying to see the occurrence of 30 here. The occurrence of 30 is for 3 times. We have 30 repeated for 3 times. When you apply count on that, it gives that. So here we can copy this again. Simply you can print it for the output. So apply a print there, print of the occurrence of, you can simply add that. What is that? We can just create this format and occurrence of some 30 is how many times we should pass it. So now dot format of, put a bracket and then close that bracket for now. That is fine. And then here that element we should pass. For which element you are testing here? You are testing for 30. You can pass it directly as a string itself because we know for which element we are checking. And then comma, we are taking the count of that. So we closed count method, we close format method, we have to close print method. That's fine. So this is the quick idea. And all of us know count gives us occurrence of some element. So we pass 30. It should return 3 for us. That's all. Run it and see output. And at the end, you can see the occurrence of 30 is 3. You can see here, friends. So this is all quick idea about these two methods which we can apply on tuple. And these methods are inside tuple class. Only these two. We don't have other methods as I repeated this statement number of times. So it doesn't have append or insert or anything else here. So we are done with testing the very important methods that were there in tuple now, that index and count. Let's switch to the next one, built-in functions in tuple. Built-in means these are not inside tuple. These are generic methods which are not inside but outside tuple. Okay, these are all different things. Length means what? Suppose if we want to find length of tuple dynamically, so that length has so many items, you want to just quickly know how many elements are there in tuple, then apply length. You can just choose this now. Okay, so now let's quickly test it. To get length of list, sorry, list or tuple, sorry, anything is fine. That's length of tuple. You can simply run this simply. You can add this in comment just for testing purpose, and then you can simply say print. Okay, the length is. I'm just going little fast because we are little running out of time. So I'm not taking too much of this thing now. Okay, the length of that tuple is okay. Simply using this length. This is a generic method. You can see here we are not saying t dot len. We are simply saying len of t. Means what? This method doesn't exist in tuple class. It is something which is a generic one, regular method, which is outside tuple. Okay. And these are applied general purpose methods applied on all these data structures, not just specific to only tuple. Okay. Now what you do, right click and then run this and see the output for last one. The maybe somewhere there is an error. Let me fix it quickly. Run it. And you can see the length is 5 because this tuple has 5 elements. So this is the one. Next one. Similarly, min max. I think this you can test it, friends. If you want, I can copy and paste all this data in your chart box. Min means it gets minimum element. What is the minimum here? 10. Okay. Anyhow, anyhow we did this till this. Why don't we do it? Okay. Anyhow, I'll paste this code in the chart box. You can also give a try with this. Okay. So now you can give a try with that. Next one. What you can do now? Just copy this and just test all this one by one. Okay. I'm not taking much time. I'm just quickly doing one by one here. So pasting here, testing all in one shot. Okay. Max return, min returns min. Okay. And then print this. So simply print that. I'm not using format now. You can apply it because take time and apply format. Of course, it doesn't take much time, but I'm finishing it quickly as we are running already out of time. No problem. 2 minutes or 5 more minutes doesn't affect anything for us. Please just wait for 5 more minutes. The min is, and here you can comment this, and then you can just print it. So you can simply say the max is here also in comment, make a small change. Max returns max of this tuple. What is max? Some 50, right? That's it. And then sorted. Copy this and then print it. And simply pass sorted of t. Don't need to print any data here. Or else if you want, you can just say simply close this first. Okay. This sorted data is okay. Simply say that. Sorted, what it do, simply sorts those data. That's all, friends. Already it's sorted. You don't have much to sort here. Okay, you can just change the order here. Some 30 to 40 put here, 30 after that, and then 50 after that. Okay, leave it like that. And then if you want to do sort in ascending and descending order, this time our job is reduced a bit. If you want it in ascending, then we should use this flag. What is that flag? One is we should pass some value to that sorted method, that tuple or list, that data structure, and then we have to apply this reverse flag. We discussed this while discussing list collection. And if it is set to false means by default it chooses ascending order. And if it is set to true means it chooses descending order. You can sort as per your need and necessity. Okay, friends. So that's about sorted. And then comparison. Okay, comparison can occur in 3 different ways. You can see here. So if two tuples are same, you can see T1 and T3 are same here. It compares 2 tuples. Okay, let me comment this. It's comparing 2 different tuples altogether. You can see here. So T1 and T3 are same. We got 0. And T2, T1. T2, T1, I don't see a clear match here. So it is giving some difference here. 1 represents it's not matching. 0 represents it's matching here. And also same thing is applied for T1 and T2. Sometimes it gives you negative output and positive output, but it doesn't mean that what is that. So when you see this -1 or 1 or -2 or 2 or something, means those you can simply just have a quick understanding. Those data structures are not matching. If it is matching, it returns 0. That is the quick idea. If you want to validate anything, through some applying some condition checks. So remember this. What is it? If compare method returns 0 means they are matching. Else, in other cases, if it is positive or negative value means they are not matching. That is the simple idea you should keep in the mind, friends. Okay, let's run this now, and you can remove this. Maybe you can or put this output in comments. Okay. Okay. Now right click and then run this, and you can see. You can see here the occurrence is 5, length is 5, min element is 10, max element is 50, sorted data is 10, 20, 30, 40, 50, And here even this is in this one is in ascending order, the other should be in descending. Where is that descending list? Should be if we say true. And here we didn't print a compare of where is the output for that somewhere. This should come for us. We are missing output for this comparison. T1, T2, T3. Okay. Okay, we'll come back here. Sorted, this is work till this we got data. Sorted of T is fine. Then sorted of T reverse equal to false. We should get output from here. So let's see if any error is there. Yes, see here. Name error. See, that's why sometimes don't see errors for here. Go to the top and see. Just do comment here. These comments are actually Java comments. While writing codes, sometimes in Notepad I just put like that. Okay, no problem. This will work now because code is fine for us. Okay, see. This time we found descending order. Still again there is some error I made, not we made. Comparison is not defined. Maybe this might work in 2.x, I believe, friends. If I put here means this is somewhere used, but saying not defined. It's not defined. Okay. Maybe this works in 2.x, I believe. Or I'll check and let you know. Not a problem. Or you can ignore this for now, friends. Leave it. Okay, this use case you can leave this. Okay, this is all about different general purpose methods. If that comparison is there, I'll just let you know in tomorrow's session. Okay, so this is all about your tuple. Okay, we had a lot of detailing on tuple, more than even list as well. List we discussed many things about it. Okay, tomorrow this is very important. I'll talk about list comprehension and tuple comprehension, which is very much used in real-time code. Even if you go to any website or somewhere, people talk a lot about these comprehensions. We'll see that. Okay. And then the very important topic tomorrow after this is dictionary. We'll see it in tomorrow.